Docker Swarm by itself works great if you don't need to guarantee that your containers can communicate directly. In some cases, it's okay for containers to not know each other's DNS names. For example, using a service discovery mechanism such as Consul or SkyDNS can allow containers to communicate, assuming their ports are made available through port mapping. In an earlier chapter, we discussed the first type of user-defined network, which is the bridge network. The bridge network allows DNS discovery on a single Docker host. Once we move into Docker Swarm in multi-host environments, we can use the other user-defined network type, known as the overlay network. Overlay networks allow containers to communicate using DNS across multiple Docker hosts. Like Docker Swarm, overlay networks require a key-value storage system to maintain information about running containers. This key-value store can be Consul, etcd, or Zookeeper. Like the last chapter, we'll just run a Zookeeper container on the default Docker host. Next, we need to start up a Swarm Master Docker host, as well as a couple Swarm nodes. Docker Machine provides options out of the box to create Swarm Masters and nodes when creating new machines. We can start by creating our Swarm Master. This time, our master will run on a new Docker host. We can pass the Swarm option to Docker Machine Create to bootstrap the Docker host as a Swarm member. Since this is our master or manager node, we also need to pass the Swarm Master option. Next, we need to use the Swarm Discovery option to tell Swarm where its key-value storage for discovery is. This time, we'll need to specify a path in our Zookeeper instance because we'll also be using Zookeeper for the overlay network. Now, we need to specify the Zookeeper URL and path for the overlay network using the engine opt option. The engine opt option allows you to pass Docker startup options through Docker Machine. So the value passed to engine opt is an option itself. We've set the Zookeeper URL to our Docker host and used overlay as the path. This will segregate the overlay network Zookeeper data from the Swarm discovery data. Next, we need to pass one more engine opt option to Docker Machine to specify the network interface and port for Docker to bind to. The final argument we need to pass to Docker Machine Create is the name of the Docker host. We'll call ours Swarm-Master. Now our master is running, so we can use the same options with Docker Machine to start up our nodes. We can omit the Swarm Master flag this time, though. We'll name our first node Node 1. Now we'll start our second node. Since we bootstrapped our machines using Docker Machine this time, we can use Docker Machine env with the Swarm flag to point our Docker client at the Swarm Master. Now that we have a running Zookeeper and Swarm cluster, we can create an overlay network using Docker Network Create, specifying the overlay driver. We'll name our network overlay-net. Next, we can run the counter web application from earlier in the course. Here, we specified the overlay network that we created as the network for this container. To ensure that our containers run on different Docker hosts, we can pass a constraint environment variable to Docker run, which we can use to constrain the container to a specific node. The constraint we're using here is the node constraint, whose value is a Swarm node name. This will ensure that our counter container will run on node 1. Finally, we'll specify our counter image name to run. I've made the counter application available indefinitely in my public Docker Hub account. Let's peek at the source real quick to remind us how the counter application works. The counter application is a simple Ruby Sinatra web app that increments a Redis counter and displays the result as a number of page views. The Ruby application connects to Redis using the DNS name Redis. With our overlay network, even if the Redis container is on a different Docker host, the communication can happen. Next, we can do the same thing with our Redis container, only we'll constrain it to node 2 to ensure that it's on a different host. And now, if we run Docker PS, we'll see both containers and their respective Docker hosts in the results. We can now copy the IP address for node 1, where our counter application is running, and paste it into a browser. Our counter application should be able to use Redis just like before, only this time on different hosts. And as we can see, the connectivity still works and our page views increment. Overlay networks are a great way to really leverage the power that Docker Swarm affords you.